Hello, friends. Today we're going to talk about a very interesting topic, which is Taguchi Design Method. It is used for design of experiment. By design of experiment, we mean it's not designing an experiment of how to do the experiment or what are the things that you need to do sequentially to get the experiment. It is not. The design of experiments meaning if you have a lot of variables involved to make a decision. For example, if you're in an industry and you are trying to figure out what are the best ingredients to make a best output for your industry and also for your customer, so you need to run tests. And also, as an engineer, you make a lot of tests to make a final decision when you have so many options. But the question comes, how many experiments you need to run? Because that involves the cost and your time. What is the optimum number of experiment that you can do to get the outcome or the result or that you need to make a decision? So we're going to design the experiments. What are the experiment combination you need to do and how many experiments you need to run? So minimum, so that you can do the make the decision. And it's a broad topic. There's a lot of many methods available on design of experiments. But today we're going to talk about only Taguchi design example. And also, depending on variables, you can have 100 variables or 1 or 2. The less the variable, the easiest. So we're going to do a simple, probably the simplest Taguchi design example. Work it out from the problem, the design array, and then the solution. We're going to see the learning objectives shortly. And you see at the very end here of this slide, we see P3L2. What does that mean? If you already know what is design of experiment is, then you might have an idea what is P3L2 means. But if not, don't worry, we're going to talk about that. So let's move on and see what we have to discuss for today. So today we're going to discuss, or our learning goal would be again working on a P3L2, and we're going to talk about that, what that means. It's very simple. So our goals for today would be how to develop an Taguchi Design Array. And again, I said there could be a lot of bigger array depending on how many variables we need. But for understanding and comprehension, we're gonna limit to the simplest design array, and which would be P3L2. And the next we'll talk how to predict the maximum outcome from the design array. So first, we're gonna make the design array. So we'll be given some variables to deal with to make an outcome. So what would be the best combination of the variables to get the best outcome? And we'll figure out what is the experimental combination that minimum combination we can do to make that decision. Next, from those tests, how can we find the maximum outcome? And when we find the outcome, is there's any confirmation experiment that we can do just to confirm that if necessary, if we have to do. Again, for the simplest tests, those are not so important. But again, we need to know how it works, and if you deal with more variables, then you may have to run confirmation experiments on top of after you make the maximum outcome primary decision. Now, then finally, we're gonna talk about follow-up experiment. It also same as the confirmation experiments. You have more variables, you may wish to run follow-up experiment, but we'll just talk about it. But for simplest Taguchi Design Array, in this case P3L2, you may not have to use it, but we're going to talk about it anyway. So let's move on. So what is the problem? So if we can define a simple example problem, that's our goal. An example So if we can define our problem, and you can see what are the variables are here, and we're going to also introduce, this is the time to introduce what is P3L2 we mean by that. So think of this image. We're trying to find the best combination of these variables in the picture. You can see that will give us a best result. So if you think we're given a task to use whether lemon and or vinegar, cotton, sponge, or how many time you're going to apply it, 5 minutes, 10 minutes. These are your variables to get most optimum combination of this any three that will give you best result of cleaning something. So if you are cleaning a dish or like a cleaning anything, what would be the best combination will give you the best result. So first parameter, we call it material. Okay, what are the material we're using? And this is called P. So we say P3L2, remember? So if we say first parameter is my material, I can have two material here, lemon and vinegar. So that means L2. So parameter 1, L2. And then I have a second parameter, which is media. I can use lemon. For lemon, I can either use cotton or sponge. So that is another parameter, and it also has level 2. So how I can have a level 3? If I have another material, for example, cotton, sponge, and you may also have a scrubber, maybe. So you will have a third level. And here also, instead of if we have lemon, vinegar, and then another maybe soda, baking soda, that will be a third level of that parameter. And then our third parameter C is 5 minute. We just put randomly, and then we can have a 10-minute washing time. We can also put 15-minute washing time, or maybe 1 minute less washing time. So that is another parameter. And then the many step you have, the more level you have. So I think up to this point, you're clear what we mean by P3L2 that we're talking about. So P is the parameter. How many parameters do you have? So 1, 2, 3, and L2 is the level. How many level of each parameter you have? Level 1, level 2. The more level you have, this will go up. The more parameter you have, this will go up. Okay, so this is our problem. This is the simplest problem in Taguchi Design. Our goal is to find the optimum combination of this that will give us the best result of cleaning time. So for example, we can have run it tests start with lemon, and then cotton. For cotton, I can do again 2, and then for sponge, from here to here again, for sponge I can do 5 minute, 10 minute, and then again we have to run the tests from vinegar. From vinegar you can go cotton. Let me use a different color so it may be easy to. Okay, so if I again start with vinegar, I can do vinegar with cotton, and then from cotton again 5 minutes, 10 minutes. I can again do vinegar to sponge, from sponge again 5 minutes, 10 minutes. And now you can think, if we have more parameters and more level, how many tests we have to run to make a decision. Well, this is the importance of our design of experiments. How statistically can we reduce the number of tests and still make the same decision that we are looking for? So I think the problem is clear to you now. We're trying to define how many minimum experiment I have to run to make a decision about what would be the best combination of these parameters and levels that will give us the best result of cleaning something. So 80% cleaning, 90% cleaning done within 5 minutes or 80 minutes. What is the best combination? So since in this lecture we're just going to talk about Taguchi Design Array, So we're going to only focus on that Taguchi design because it's beneficial, and we're going to talk how benefit it is. So the Taguchi rule is, when you design an experiment, the first rule is each level of each parameter appears the same number of times in an array. And we're going to talk about that, what we mean by that. And then there is only second rule, so two rules for Taguchi method. Rule 2 is repetition of parameter level combinations are maximized as much as possible. Minimized, I'm sorry. Repetition is minimized as much as possible so that the number of tests is minimized. So the benefit, in a simple words, there's a lot of discussion you can find. In simple words, Taguchi design experiment is a robust method that drastically reduces the required number of tests you need to perform to find an optimum result. So what is the minimum number of tests you can get away by just running a minimum test to get the result? Thus reduce the costs if you're working, or even for your personal case, you can reduce the cost of running an experiment and also save valuable times. So there's a lot of importance of the Taguchi design. So let's see what is next. So for our first learning objective, we will design the Taguchi Design Array, meaning the experimental combination that we have to make so that it is minimum as defined by Taguchi. So let's see. And we're also going to show you what is a full factorial, meaning another testing design test arrangement for P3L2 3-parameter 2-level, which is called full factorial, and we're going to see how Taguchi reduces the number of tests. So if, just for example, if we can assume to visualize this P3L2 scenario, if we go further than P4, L3, P5, L6, those cannot be visualized because you have a denser matrix of array. But for P3L2, we can show you the arrangement using a cube. So if you assume that your x-axis here, A, is your material, the first one. Let me use different color. It's a material, right? So if this is material, you can assume the B, the y-axis here, as your media. And then your c-axis as your time. So these are 3-parameter line. And for each parameter line axis, you also have, we had a L2, meaning level 2 level. So I have first level at the center and second level here. So if it's my first center would be lemon, this would be vinegar. Again, for B, media, the first level would be cotton and the second level would be sponge. So just to visualize how many combination you can have. Again, for the last one, time, you have a 5-minute test or 10-minute test. So these axes are the parameters, and this I have 2 levels, and those are marked by this point. And then if we connect all those points, I can have a cube, which is the full factorial test. So it says that you may need to run at least 8 tests because you have 8 points here. Just to show you, let me use a different color. Maybe a violet. Okay. So full factorial test, it tells you that maybe, well, you have to run at least 8 tests. 1 here, this is a combination ABC. Again, 2, 3, 4, 5, 6, 7, 8. And this is the 8 tests that you may need to run to make a decision. This is called full factorial test. And what are the combinations? If you put those here, so A1, B1, C1, this is A2, and this is A2, C1, B1, and you have the coordinates of each point that you already know. So if we do that and put those values, I will have this test set up. For example, for the first test, you have to run lemon cotton and run it for 5 minutes and get the result. For the second test, you have to run, so this will be your second, lemon cotton and for 10 minutes. Third, lemon sponge 5 minutes, and so on and on. The Taguchi method is useful because he said you can run only 4 tests and get the full output of this running 8 tests. Better, huh? Because you can just get away by running 4 tests, but you can make the decision without running 8 tests. But, and what are those tests? Taguchi said you have to run only, let me show you the dots. Taguchi said that instead of running the 8 tests, you only can run this one, this one, this one, and that one, and you can get away with it. You don't have to do this one, this one, this one, this one. So for level P3L2, you can reduce your number of experiments needed by half. Instead of 8, you need 4. Since we reduce the number of tests, we may need to do some averaging in order to find the effect of one parameter on another. One more thing before we move on. In general, for a full factorial test, if you know your number of parameters and number of levels, in general, you have to run how many tests you have to run can be determined by L to the power P. So if you have 3 parameters and 2 levels, so it will be 3 to the power 2. It will be 2 to the power 3, 2 to the power 3, which is 8. Now, if you have a setup where you have, for example, L3, P4, meaning you have 4 parameters and 3 levels, you may need to run 3 to the power 4, that would be 81 tests. But if you use Taguchi Design Array, you can still get the same results and same outcome. You can make a decision for P3L2 by running only 4 tests, and we're not going to talk about this one, but again, if you use Taguchi Design Array for P4L3, you can get away just by running only 9 tests for Taguchi. So that's a huge saving. So that's why we emphasize learning Taguchi Design Array. So now let's move on. When we design this array, this is the test matrix. Now we're going to run the test and assume some results, and from those results we're going to determine what is the maximum combination. So let's assume that we did choose the Taguchi Design Array and we figured out what are the Taguchi test run is. We also told you about the rules of Taguchi, that each level of each parameter appears the same number of time in the array. So what it means, the rule number 1, so each level, which is lemon vinegar, cotton sponge, and 5 minute, 10 minutes. So you see each of them appears, so each level of each parameter appears same number of times. So lemon appears twice, vinegar twice, cotton twice, sponge twice. This is first rule. Repetition of parameter level combinations are minimized as much as possible. Well, again, you will not see a test which is similar. The combination are not same. So vinegar sponge 5 minute. There is no other test which is vinegar sponge 10 minute. right? So we're reducing the number of tests. So again, now we have our result. So that was the second rule. Now we have our results. Assume that after we run these tests from Taguchi Design, we found the result as the first combination gives you 40% cleaning, the second combination gives you 60% cleaning, the third combination gives you 70% cleaning, and then the final combination gives you 50% cleaning. So now, from this, how can we determine which combination will be the best outcome? Or there is also a big question. The test we have not run, the other four, remember, is it possible that the test that we didn't run, the result is out there? So what I'm saying that the maximum outcome is not a one, which of these four, it lies on the other four that we did not run. Well, we're going to talk about that later. But for now, let's move on how to make the decision after you run the test using the Taguchi Design Array. So first we have to do some average because we did not run the full test. So I have to find the average for each level of each parameter. So A1, I can find it by x1 plus x2. So how did we find this equation? Again, you have to figure out in which test A1 means material 1 level 1, so material 1 lemon, level 1 lemon, so lemon where it belongs, experiment 1 and 2, so we just take 1 and 2, divide the average. And for again another example I give you, we can have the average of material 2, parameter 2, level 1, so which would be my cotton. So second parameter B is media, and then its first level is cotton. And where this cotton belongs, experiment 1 and experiment 3. So I take average. So this is how you take the average of each parameter, each level of each parameter. So I had in total 6 levels, so that's why I had 6 equations. Now I'm going to take the average from this result and I'll show you the results. So we have taken the average of each level, each parameter, and we see 50, 55, 45. You can check later. Now we have to look for the trend, how the effect of each level of each parameter affects the total outcome, which is the x, right? So what we're gonna do, we're gonna plot this trend for a parameter. So parameter A, we're gonna plot what is the effect if we change from level 1 to level 2. What would be the effect for parameter 2, which is media, level 1, level 2. Now let's, and same for the third parameter. So now let us plot this trend. So now we have plotted all the averages for each parameter. So for material, we plotted a level 1 to level 2 average, so 50, 60. So we see that for material, if we change from level 1, from lemon to vinegar, the effect of the total outcome is increasing. If we switch to media, we saw that the effect of media changing from cotton to sponge to cotton is still 55 to 55. So it is there is no effect if we switch from cotton to sponge. And then the third parameter, this is the plot that gives us. If we plot it, so if we plot for C1, we find that changing for C1, the effect of C1 into the total outcome, if we change the level from 5 minutes to 10 minutes, again it has increases. So if you do it for 10 minutes, you will get better result. Again, to mark and show you what exactly I plotted here is, this is the XA1 from previous slide, this is the XA2, this is the XB1 average, or both are average, and XB2 average, and this is XC1 average, and this is XC2 average. So from this plot, we're gonna see what are the effects of each level of each parameter on the total outcome. So in this case, we have only 3, and it's simple. But in general, there can be 5 outcome possible. Which first one is there's no effect of a level change, which is a plateau, 55-55, no matter how many level you change. So it is called no effect. You can have increasing, and we see this is the increasing from level to level. You also can have decreasing that we do not see here, but for some case, moving from level 1 to level 2, you may have this pattern, and that you can say it is a decreasing. You can also have, if you have more parameters, more levels, you can also have maximum, meaning like this. So you can have, for one parameter to another, you can have increasing and then decreasing. We call it a maximum scenario. And you can also have the opposite. As you can guess, you can have like this, where you will have decreasing and increasing. If you have more levels, right? In this case, we have only 2 levels, so you can see that. So this is called minimum scenario, maximum scenario, decreasing scenario, increasing scenario, no effect. We have only 3 here, 2 here, increasing, no effect. We can have decreasing, maximum, or minimum. So these are the scenario you can have in your plots, average plots, if you have more levels and more parameters. But for us, we don't have much. We have 3. So now what is the next step? The next step is to find the maximum outcome. So how do we find the maximum outcome from those plot? So from those plot, we have to take the maximum point where each parameter occurred. So for material A, we saw upward trend. For B, it was a plateau, and for C, we had upward trend. So to get a maximum value, we have to take where the maximum thing occurred for each parameter. So for this case, for material, we can have to take the maximum one, which was level 2, A2, right? For B, it doesn't matter whether we take B1 or B2, so cause and response doesn't matter. Again, for C, the last option was maximum, so we have to take this one. So this one was what? 10 minute, and this one was what? Vinegar, because level 1 was lemon, and for B, it doesn't matter. So from here, we can find the best outcome will be fine if you use A2, C2. Now you have 2 options, B1 or B2, because B1 or B2 doesn't matter. So the best combination will have vinegar. C2 is 10 minute. Now you can have either cotton or sponge. Now which one you should decide, whether you should go for cotton or sponge. Take your time and think. Because both of them gives you the best combination. Now it depends on your cost or availability. Which one is available to you at lower cost, easily possible, you can use that. So from here, we can conclude that if we have a setup of vinegar and 10 minutes, we can have the best result whether you use cotton or a sponge. So now from here, we can see we already run this test. So we can see this is the combination that will give us best result. So now we can conclude the test just running by 4 tests and say we can report that vinegar, cotton, if we use it for 10 minutes, we'll get the best cleaning without running all those tests. Remember, we did not run the 4 other tests, and we don't know how much cleaning you can get from those, but just by running 4 tests, we can conclude that this is the best. You cannot get more than this in other tests. If you run, you will not get more than this percentage. So cool, huh? We reduced the number of tests and we made a decision. But so we are happy. But this is not be as simple if we have more parameters or more levels. So we may not be as lucky. It could happen is that if you take all the maximum point and make your test combination, that test combination may not fall here. For example, if somehow we ended up having vinegar 10 minutes for sponge is the best result for somehow. Now we see we have not run this test here. We run vinegar 10 minutes for cotton, but we did not run test for vinegar 10 minutes sponge. So what should we do? So that is called the confirmation experiment. If you have that scenario where if you take okay, let me go up. If you take the best of each, and then you run the test, and that doesn't belong to the test you run, you may want to run a confirmation test using the final combination that you find. This is called a confirmation experiment. This is the one additional experiment that you need to run on top of Taguchi if that doesn't fall under the 4 tests. Okay, so what next? You can also have a follow-up experiment in some cases. In this case we don't have to, but what would a follow-up test look like? So you might also want to run a follow-up test if you have a lot of parameters and a lot of variables. If you have, for example, one parameter, material, you have 3 levels, and you have a maximum. So you have from level 1 to level 2 to level 3, you have a maximum. So you go up and down, and you know that you're using this one. Often, or not often, sometimes you may want to change the value of this maxima here. Maybe here, change it a little bit to see if that combination is still stands, or maybe a little bit different. So it's another follow-up test you may run if you have more variables. Again, you can also do the same thing if you have, in some cases, if you have a minimum, meaning you go minimum and again go up. So trend, minimum trend. So once you figure out that you're gonna use if you are looking for a minimum result, then again, in that case, you may change that variable a little bit from that minimum to see if that is still stands. So this is a follow-up test. For this case, we don't have to do a follow-up test. So what's next? Do it yourself. How? Now is time that you apply this method, follow this step, and do it yourself. So one example is export that we're gonna do for our class. We can have a lot of variables that we can change. We can have our ball. If we have 2 different types of ball, that will be one parameter. We can have rubber band, maybe not, because we have, or we can change rubber band from 1 to 2 rubber band, 3 rubber band. That's one another parameter. You can also have disk, the release angle. You can have change this angle. So there will be another parameter from this angle to that angle, different level locking. See, for this one, you can lock here, here, here. You can have another parameter locking ping, and for each parameter, you can have more levels. And you can design this test experimental array and see what combination gives you the maximum distance of that ball. Or you can look for what combination will give you to hit the ball into a pot, right? And then you can It's a fun experiment you can do, and then figure out or learn the Taguchi Design Array at the same time, doing minimum run of the test. Okay, so that, I believe, yeah, that is it for today. In future, we're gonna come up with some more exciting sessions, but till then, thank you. Have a great day.